let's look at this question where it says listed below are the ACT scores of 40 randomly selected students at a major university. So first of all, we know that our N is equal to 40. We want to construct a grouped frequency distribution and a cumulative frequency distribution. So that just means that we want to find our class limits, our midpoint, frequency, relative frequency, and cumulative frequency of this data using 5 classes. So we have raw data here, and we want to find 5 classes. So a couple of things that we need to note is that we first have to find the class width, because we're not given the class width here. If we were already given the class limits, we would know the class width because that's the difference between the lower limits here, but we don't have any lower limits yet. So the class width is going to be our highest value minus our lowest value divided by the number of classes. And when we do this, we're always going to round up to the next number. Since our data is whole numbers, we're going to round up to the next whole number. If we had 1 decimal, we would round up to the next 10th, that sort of thing. So in this particular case, whenever we do our calculation, we're going to go up to the next whole number. Even if we calculate a whole number, we will go up to the next whole number. So if we calculate 4, we're going to round up to 5. You never stay on the exact value that you calculate for class width. And this is because you want to make sure that that highest value is in there. Think about if you go into a grocery store and something costs exactly $4. Well, class width is like how much money you go into the store with. If these are the cost of the items, if you go in with $4 and something costs exactly $4, you're not going to be able to get the item because you have to give yourself some buffer room for things like tax. Okay? So our buffer room is where we round up to the next whole number. We go in with $5 to cover the tax. So our class width here, we go through here and we find our largest value, which our largest value is going to be 32. And this kind of tells me my smallest value. My smallest value is going to be 11. So I'm going to take the difference, 32 minus 11, and I'll divide by 5. 32 minus 11 is going to be 21 divided by 5. That will give me a 4.2. So my class width that I'm going to use is actually going to be 5. Think about something costs $4.20. I have to go in with a $5 bill. Okay, I can't go in with $4. So as I create my classes, it tells me I'm going to start at 11. Usually you start at your lowest value. And then you are going to add that class width down, not across. You're going to add it down. So you're going to add 5 to each of the lower limits. When you're filling these out, make sure you fill out the lower limits first. Don't even touch the upper limits yet. Always fill out the lower limits first. So I'm going to add 5. And so I'm going to get 16, 21, 26, and 31. Then I go back in to fill in those upper limits. So if this class starts at 16, I'm going to subtract 1, this class is going to end at 15 because they have to be continuous. If this class starts at 21, this class is going to end at 20. Now you'll notice, what's the difference between your upper classes? Upper class limits. Well, it should be the same as your lower class limits. It's 5. So I should be able to just say 25, 30, and 35. Once I find one upper limit, I should be able to just add that class limit or class width down. Now let's look at the midpoint. Our midpoint, please be careful, it is not these two. It is actually lower limit plus next lower limit divided by 2. Because technically this should be going to 15.9999, 20.9999. In other words, these are continuous values. It goes up to the very next number. So our midpoint is actually going to be 11 plus 16 divided by 2. And we get 13.5. We don't round midpoint. Midpoint is kind of like our median, things of that nature. We don't round it. So we calculate midpoint and leave it as is. Now if I were to do 16 plus the next lower limit, 21, divided by 2, I would get 18.5. Now notice, what's the difference between these two? 18 minus 13.5 is 5. I'm going to add this class width down. So I will get 23.5, 28.5, and 33.5. Class limits and midpoints are going to increase by this class width all the time. Okay? Now your frequency, you're literally going to go through here and count up how many values in this data set are between 11 and 15. How many data values are between 16 and 20, and so forth. So I recommend that you pause the video and count those up, and then restart it to see if you get the same numbers that I did. So go ahead and pause the video. Now that you've come back, I hope that you got 9, 14, 12, 4, and 1. If you didn't, you might want to go back and double check yourself. Relative frequency, remember you're going to take the frequency, so this 9 divided by how many total values you have, so you're going to take 9 divided by 40, and it tells us we're going to round to 3 decimal places. So that's going to be a 0.225. We're going to take 14 divided by 40, so that's going to be a 0.350, a 0.300, a 0.100, and a 0.0, let's see here, 0.025. Cumulative frequency means we accumulate our frequencies as we go. So we're going to start with the 9. So everything from 11 to 15, there are 9 values. Then we go to the next class. We don't lose these 9 values. We include the 9 and we add 14 to it. So this is like saying 9 plus 14. And we get 23. Then we're going to take that 23 and we're going to add 12 to it. So we get 35. And then 35 plus 4, we get 39. And 39 plus 1, we get 40. This last one should be your N, your sample size. So practice this and let me know if you have questions.